everyone, my name is Anke Ellis and I'm the Director Marketing and Communications at IHSE. I'm here today with my colleague Mark. Mark, tell us who you are.
Hi Anke, I'm Mark Hempel and I'm responsible for the product management here at IHSE.
Lovely. And let me just tell you very briefly what we actually do. We develop and manufacture KVM extenders and switches. We do that here ourselves in southern Germany, and this is also where our headquarters are. We do have, of course, subsidiaries in the US and in Asia. Our products are quite well known, very well known actually, for their quality and reliability. So we are used a lot in mission critical applications, which could be in air traffic control, of course in broadcast and medical, for instance. Today we're talking about esports to you. We create the integration, we allow the integration of content processing and the broadcast workflow in one. But let's see what that actually means.
Well, basically what that means is something different to us than what we've done before with broadcast signals. What we're doing with esports now, we have not a camera signal anymore, or not just camera signals. Camera signals are just being used for the stage, but here the content basically is generated by the PC itself.
So that means actually the camera signals comes in at what kind of frequency normally?
Well, camera signals usually come with let's say 60 frames a second or slightly less, depending on whether it's PAL or NTSC. But with esports we have a PC basically acting as the source, and as we all know, esports is no longer really based on large widescreen displays like the curved one we have in the back end. We're more going into focusing the area of the game, playing at full HD resolutions but at higher frame rates, such as 120 frames a second and 240 frames a second.
And actually, if I remember correctly, the signal that comes from the PC is at 240 Hertz. So instead of the camera signal coming in at 60 Hertz or 30 Hertz. So you have to receive them in a different kind of frequency.
And that's basically the key element why we're now in the chain of the whole content production and content creation part of the broadcast, and that's the first time for us. And that basically is the fun part here, because broadcast equipment is not capable of having an ingest of 120 frames or 240 frames a second. So they simply can't handle it, especially once you want to produce some kind of nice content.
So basically that's a new kind of broadcast scenario. We can now receive the signal still coming from the PC and only the PC at 240 Hertz. We can break it down, and therefore we make it available to everybody who needs to use it in whichever way they need to use it. So the directors, they can then pick out a 60 Hertz frame and choose the content they want to create with that and broadcast it on the big live screens. They can push it out to social media, they can push it out to the online people, and the gamers still can use that 240 Hertz signal.
Absolutely,
right?
There is no impact on the gamers at all.
Yeah.
They can still run with their native signal if they like. There's another different subject of running this through the KVM matrix that we supply. We have some proven statements from gamers that even used it through our extension and matrix technology.
Yesterday something interesting happened. I had some other professional gamers from UK, and they asked me that what was we were displaying about this, and I talked about how the gaming machine goes through our extenders, through the switch, through the other set of extenders, and then they are playing at such a high frequency monitors, 240 Hertz. So he said, no, there has to be delay. It cannot happen without a delay. I said, well, here are the professional gamers also. Why don't you go and ask them? So apparently they walked to these guys and they asked, and they said there is absolutely no delay, and that we can confirm with him. She's taping you.
Right.
Do you feel any delay at all?
There is no delay whatsoever. It's direct input. It feels like direct input.
It feels like direct input. Any mouse stuttering when you click anything? Any
Nothing.
shots that you feel that you missed or anything like that?
Not at all. Not at all. No.
Lovely.
So this is what the gamers had asked them yesterday, and this is what is all about IHSE.
That's still not everything we can do when it comes particularly to esports. We can also produce the world's first super slow-mo. And Mark, tell us how this works, please.
Well, Anke, this is basically one of the things that we developed in cooperation with our partner EVS. We're doing a synchronized sequential frame rate conversion, and we're taking out of this one 1080p 240 Hz stream, taking this and cutting it down into 4 individual streams of 1080p 60 to deliver it to 4 of the ingest ports of the EVS system to capture every single frame, and then afterwards being able to roll it out frame by frame for the super slow-mo. So we need to get the feeds into the broadcast equipment, such as an EVS, for example, to create on all the shooter games, wherever there's big action going on. It's fascinating, like in all other sports events, to see some kind of more detailed action in place, and that's basically done with slow-mo or super slow-mos.
Okay, I hope we could give you a very brief overview over what we can do in the world of esports. It's going to grow massively, and we are part of it. So please get in touch with us if you want to have any more information. And this is it today. Bye from me and bye from
Mark, see you.